Hello, good morning everyone. In our previous lecture, we have already seen in how we solve the different types of question according to moments with assuming or actual mean. So, our next example is find the first four moments about assumed mean is 25. We are given in assuming considering 25. So, in our question, we are given in the class interval, not in the value of only x. This is the class interval. Class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40. See the screen. This is what is the format of the class interval? Inclusive or exclusive? Exactly. This is the exclusive form because of the one interval is upper limit is equal to other interval of lower limit. So, and given x is equal to 1, 3, 4, 2. So, first we find the first four moments about the assumed mean. We have the value of x. Value of x आपके पास होना चाहिए. Okay. So, हम कैसे find करेंगे? So, the mid value of x is 0 to 10. The mid value is 5. 10 to 20. The mid value is 15. 20 to 30, the mid value is 25, and 30 to 40, the mid value is 35. So, according to our assumed mean, we are already given in, we consider assumed mean is 25. So, don't be confused, we use A is equal to 25. But in case we are not given in the assumed mean if you consider 25. So, हम क्या कंसीडर करते हैं अकॉर्ड 15 and 25 both are middle values. We consider 15 or we consider 25, but according to our frequency the rule is if the greater than frequency is what, the largest value is 3 or 4. So according to 4 the mid value is 25. So we consider our A mid assumed mean is 25. Got it? So first we find b is equal to x minus a. That means what? 5 minus 25 minus 20, 15 minus 25 minus 10, 25 minus 25 0, and 35 minus 25 is plus 10. So finding the first four moments, we map the table. First table is f x minus a. Second table is f x minus a whole square. Third table is f x minus a whole cube. And the fourth table is f x minus a to the power 4. Got it? Solve this table. Okay. Pause the video for 1 or 2 minutes and आप ये टेबल बनाइए कि टेबल में वैल्यूज क्या आती है. Got it? So moments about the assumed mean. Assumed mean, that means arbitrary value. So we write the mu1 dash, mu2 dash, mu3 dash, mu4 dash. Got it? So our first mu1 dash is equal to what? Summation x minus a divided by n, where n is equal to 10. Capital N is equal to 10. mu2 dash is equal to summation f x minus a whole square divided by capital N is equal to 90. mu3 dash is equal to summation f x minus a whole cube divided by capital N. That means minus 900. And mu4 dash is equal to summation f x minus a whole raised to the power 4 divided by capital N is equal to 21,000. Okay, so moments about the actual mean. Moments about the actual mean. In case we are finding about the actual mean, so first we find the assumed mean. Got it? Moments about the assumed mean, and after that we find the moments about the actual mean if we are given. Got it? So mu1 is equal to 0, mu2 is equal to mu2 dash minus mu1 dash whole square is equal to 81. mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu 1 dash whole cube is equal to minus 144, and the last value is mu 4 is equal to mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash in the bracket mu 1 dash whole square minus 3 mu 1 dash whole raised to the power 4, and we get the value of 14817. So this is the example of the finding the first four moment about the assumed mean. For example, we are given in the first four moments about actual mean also. So first we find the assumed mean value, and after that we use the relation about the assumed mean or actual mean. In case ये इक्वेशंस आर सो कंफ्यूजन, यदि आपको इक्वेशन में कंफ्यूजन होता है, so again we make the table according to our actual mean. Got it? That means what? X minus x bar whole square, x minus x bar whole cube, and x minus x bar whole raised to the power 4. After that we multiply f. That means the next four column is what? F x minus x bar, f x minus x bar whole square, f x minus x bar whole cube, and f x minus x bar whole raised to the power 4. That means what? If we use the assumed mean, we multiply f into x minus a, and if we used the actual mean, we multiply f into x minus x bar. Got it? So this is the topic of the moments, first four moments. After that we find the coefficient of correlation. What is the correlation? Our next topic is coefficient of correlation. So correlation is the relationship that exists between two or more variables. That means two or more variables correlate. This is called the correlation. Two variables are said to be correlated if a change in one variable affects a change in the other variable. That means what? If we change in the one variable, then automatically change in other variable. Such a data connecting two variables is called bivariate data. Next, when two variables are correlated with each other, it is important to know the amount or extent of correlation between them. The numerical measure of correlation of degree of relationship existing between two variables is called the coefficient of correlation and is denoted by a small r. The coefficient of correlation is very important topic in this chapter, and it is always lies between -1 and +1. If we find the coefficient of correlation or correlation coefficient, so always the value of r is -1 less than equal to r less than equal to +1. So we write the -1 less than equal to r less than equal to +1, but the value r is between -1 to +1. That means -1 less than r less than +1. So the conditions are when r is equal to 1, it represents perfect direct or positive correlation. The second is when r is equal to -1, it represents perfect inverse or negative correlation. That means keep in mind, if r equal to 1, the positive correlation, and if r is equal to -1, then the negative correlation. When r is equal to 0, there is no linear correlation or it shows absence of correlation. Got it? So next is the types of correlation. This four steps is very important. The types of correlation. First one is positive and negative correlation. Second one is simple and multiple correlation. Third one is partial and total correlation. And the fourth is linear and non-linear correlation. So the first one is positive and negative correlation. What is a positive and negative correlation? The definition of both correlation is what? So depending on the variation in the variables, correlation may be positive or negative. First is positive correlation. If both the variables vary in the same direction. Listen carefully. If both the variables vary in the same direction, the correlation is said to be positive. In the other words, if the value of one variable increase, the value of the other variables also increase. Or if the value of one variable is decreased, the value of the other variable also decrease. For example, the correlation between heights and weight of group of person is a positive correlation. That means height के according weight इंक्रीज होता जाता है जैसे जैसे हाइट इंक्रीज हो रही है वेट इंक्रीज हो रहा है सो दिस टाइप ऑफ एग्जांपल इज अ पॉजिटिव कोरिलेशन सेकंड इज नेगेटिव कोरिलेशन if both the variables vary in the opposite direction. In positive correlation, variables vary in the same direction. But in negative correlation, variables vary in the opposite direction. Correlation is said to be negative. In other words, if the value of one variable increase, the value of the other variable also decrease. That means what? One variable is increased, then the other variables also decrease. Or if the value of one variable decrease, the value of the other variable also increase. That means both the values of the variables are opposite. Okay, the correlation between the example is the correlation between the price and demand. Price and demand of a commodity is the negative correlation. That means what? यदि price high है, then demand आपकी कम होगी. लेकिन if price कम है, तो उसका demand ज़्यादा आता है. So this is the positive correlation and negative correlation. Remember it. If the variables vary in the same direction, that means positive correlation, and the variables vary in the opposite direction, that means negative correlation. Next is simple and multiple correlation. So, depending upon the study of the number of variables, correlation may be simple or multiple. The first is simple correlation. When only two variables are studied, only two variable per study हो रही है, the relationship is described as simple correlation. For example, the quantity of money and price level, demand and price. That means what? Only two variables we used, money and price level or demand and price, etc. This is the simple correlation, example of the simple correlation. The second is multiple correlation. When more than two variables are studied, that means more than two variables पर यदि study होती है, the relationship is described as multiple correlation. That means only two variables, this is a simple correlation, and more than two variables, this is the multiple correlation. For example, relationship of price, demand and supply. So these are the three variables. Relationship of price, second is demand, and third is supply of a commodity. Okay. The third type is partial and total correlation. So Multiple correlation may be either partial or total. That means partial and total correlation depend on multiple correlations. So the number one is the partial correlation. So what is the partial correlation? Firstly is the partial and total correlation depends on the multiple correlation. So first is partial correlation when more than two variables are studied excluding some other variables. More than two variables hai excluding some other variables, the relationship is termed as partial correlation. And the total correlation is when more than two variables are studied without excluding any variables. More than two variables hai, but without excluding any variable, the relationship termed as total correlation. And the last is linear and non-linear correlation. So depending upon the ratio of change between two variables, see here, depending upon the ratio of change between two variables, the correlation may be linear or non-linear. So number one is linear correlation. If the ratio of change between two variables is constant, two variables का जो भी ratio है वो कांस्टेंट है, the correlation is said to be linear. And the non-linear correlation is if the ratio of change between two variables is not constant, the correlation is said to be non-linear. This is the simple theory of according to coefficient of correlation. So keep in mind correlation is four types of correlation, and this is a simple definition and examples. Next one is method of studying correlation. This is very important part. There are two different methods of studying correlation. Number one is graphic methods, including scatter diagram and simple graph. And the second is mathematical methods, Karl-Pearson coefficient of correlation and Spearman's rank coefficient of correlation. In our syllabus, these two methods are included. Got it? Graphics method is not in our syllabus. So mathematical methods, Karl-Pearson coefficient of correlation and Spearman rank correlation of coefficient. That means the coefficient of correlation, small r, the name is Karl-Pearson coefficient of correlation. And the rank coefficient of correlation, the name is Spearman rank correlation of coefficient. This is a very interesting topic according to our formula. Karl-Pearson product moment method. That means Karl-Pearson coefficient of correlation. So this is most popular and widely used mathematical method. In this method, the degree of correlation between two variables can be measured by the coefficient of correlation, and it gives not only magnitude or degree of correlation but also its direction, not in magnitude, also its direction. So we are given in the pair because of correlation is always depend on two variable or more than two variables. So we are given in the points x1, y1, x2, y2 up to xn, yn. The n pairs of observation of two variables x and y. Then coefficient of correlation, small r, between x and y is defined by the formula of the coefficient of correlation is r is equal to summation x minus x bar into y minus y bar. In our question, we are given in the column of x and column of y. First, we find the x bar and y bar. So, what is the x bar? What is the x bar? The mean of the column of x and mean of column of y divided by small n. Small n, that means number of terms. sigma x into sigma y. Sigma x, that means standard deviation of x. Sigma y, that means standard deviation of y. So our formula is, this is the very important formula for finding the correlation coefficient or coefficient of correlation. So small r is equal to summation x minus x bar into y minus y bar divided by under root summation x minus x bar whole square and under root summation y minus y bar whole square. This is the first formula. The second formula is R is equal to n number of terms, summation x y, that means the column of x and column of y. First we multiply x and y, and after that sum the value of x into y, minus summation x into summation y. These two values are different because of first we hide the summation, so our column is x into y, got it. But in this step, first we find the summation x, that means what, sum of the term of x, and summation y, that means what, sum of the terms of y. So divided by under root small n summation x square minus summation x whole square and under root summation y square minus summation y whole square. This formula is used for small number of items in two variables. If we are given in the column of x and column of y and value is so small, so we use this formula. And the next formula is R is equal to small n summation dx dy minus bracket में summation dx bracket में summation dy divided by under root small n summation dx square minus summation dx whole square and under root n summation dy square minus summation dy whole square. Don't be confused here. Dx and dy, if we use the assumed mean, that means assumed value, so d is equal to x minus a. Okay, if we use d is equal to x minus a, then we write dx, and if we use d is equal to y minus b or y minus a, so we write the dy. So this type of formula, deviation by assumed mean, got it. So if we use the assumed mean according to our column of x, then we write small a, and according to column of y, we use assumed mean is small b. So dx is equal to what, x minus a, and dy is equal to what, y minus b. And a last one is r is equal to covariance x comma y divided by sigma x dot sigma y. So I will continue this topic in our next session.